Hey, what's going on, guys? Coming again here. In this video we're gonna reach the milestone point in the chess engine development process, and this milestone is known as the perf testing. I've been mentioning perf testing really numerous times along this series already, and it would consist of up to two videos. So in the first video, in this one, we'll create the perf driver that would actually allow us to do the actual perf stuff, actual recursive move generating stuff, followed by actually traversing this move of trees. And in the next video we'll create the perf test function that would be printing the perf driver's results. So only in the next video we will make sure we'll figure that out, whether our move generator works or it has some bugs in it. Well, I don't know. Probably it's impossible to pass the perf test from the first time. Well, at least I never managed to do this before, but we'll see. So anyway, let me just try to think what I need now. So probably the tricky position is kind of still the same there. So yeah, let me just scroll down, open the terminal in the current working directory, and by typing make, I just want to compile the source, and if it compiles, I just want to run the binary executable produced by the compiler called chess hexadecimal 88. Okay, so this is the output from the previous video basically, and I want to grab this code. So okay, I don't need to create moves manually anymore. From now on we would be making use of the moves generated by the move generator. Define board state variable. Yeah, this stuff is needed here. Okay, so I probably want to grab all this stuff and just provide a little more commentary. So parse fn string here. Okay, initially printing the board. Yeah, well, this is possible. So now let's create perf driver. So I want to create a void function called perf driver, and I just want to paste the code in here for now. But before we proceed, let's specify the arguments taken by this perf driver. So it would be taking the depth. So in order to so we would be calling this perf driver recursively. Okay, and what else a part of depth we need? Okay guys, just hold on a second. I'm gonna check one little thing there, and I'll get back right in a moment. Yeah, I guess this depth is literally enough, well, at least for now. And we also need to, I need to grab this move generation stuff back here as well. I mean, paste this within the perf driver, and I just want to call my perf driver. So paste, and we'll start with the depth equals to 1. Okay, so let's say like run perf driver, save, and here, so here we create the move list. Okay, we generate the move. So from now on this move list contains moves. So now we can already loop over the generated moves. So for and integer move count is equal to 0. Now move count is less than I guess less equals than. Now I'm referencing my move list structure and the count within my move list. So remember the move list structure. Let me just demonstrate you this quickly. Oh my god, where is our move structure? Moves. Okay, let's search for it. It should be. Okay, this is it. So it has the list of available moves and also this count variable, okay, which we use as the range within this moves to iterate over. So move count is less equals than move list, then count within the move list. I'm just wondering, so the move list count, is this less equals or less? Hold on guys, just want to check out one more little thing here. Yeah, it's a little bug here, so we need to say like only less the move count, because we increment our move count so imagine we generated the very last move and then we just made like move list count plus plus, so we just incremented that. And if we do this like less equals, it can reference the move being generated in the previous iteration within the call of the move generate function. Just forget what I've just said. You don't really need this. So just less than move list count and move count plus plus. And now I want to enclose all this stuff within this for loop. Okay, and just to check out some more things. So the moves that we're supposed to be making here, so in order to get this move that we've been encoding manually, I just need to reference this move list indexed by the move count. So this would be giving us the exact move that we're currently iterating over. I've been demonstrating this before, and we've been doing this within print move list function. So if I just can quickly find this print move list, I'll show you this. So print move list, yeah, here. So this is literally the same move, and this, yeah, move list moves index. Oh, move list moves indexed by the index. Yeah, probably I missed that. Yeah, move list is a structure, so obviously, yeah, move list moves. My god, what have I done? Move list moves like this, indexed by this move count. Yeah, now this should work. This only captures doesn't work because for perf driver we need literally all the moves, because otherwise we won't pass the test, because just the test involves all the moves, not only captures. So all moves. I really hope this is called all moves. Yeah, it is perfect. So we didn't enumerate this. We didn't encode this all moves to be like 0, and only capture is just a way to represent the one number. Okay, what else? What else do we need here? We need to skip those moves that are not legal. So we can say if, and we say like if not make move, or other words, if make move function equals to 0, then in this case it means that the make move function has returned 0, which happens assuming that we use an all moves flex. It returns 0 only in case of the illegal move. So in this case we just want to continue our loop, so just skip it basically. So here I say like skip illegal move, okay, and here we can say make only legal moves. This is it. This is very simple. And now a couple more tricks with the print board stuff. So, okay, so we did generate our moves. Now we're looking over the list of generated moves. So we're preserving our board state, defining variables to preserve the board state. We're actually preserving our board state. Then we're making a move. Okay, so it would be nice to get the board printed before the move is actually made. So print move, print board before the move is made. And I also want to make use of get character standard function from the I'm not sure, I guess it comes from the stdio.h. Yeah, it should have in order to interrupt the program flow, interrupt the execution with getting the input from the user. So this is just needed. This is needed just in order to avoid printing really lots of boards for all the moves. So we just want to watch them as the moves comes, basically, not all at once, basically, right? Okay, so we just want to print the board before the move is made and get characters to just interrupt this. Then we want to print the board when the move is made. We'll later on we'll get rid of this stuff, obviously, but just for the demonstration purposes I want to show you this. So we print the board after we made our move. I'm just wondering. So for the illegal moves, for the illegal moves, it won't get here, right? So for the illegal moves, we just drop the execution here and go to the next iteration. Yeah, perfect. So this fires only in case only for the legal moves, and I want to get character here as well, just to pause the execution, and then we just restore our board position. And do I need to get character here? Well, it would involve pressing whatever key too many times, but okay, let's just make it here, just to handle all the possible cases. Well, okay guys, so now the moment of truth, I mean the first part of the moment of truth is about to come. So, ladies and gentlemen, well, I really doubt that there are any ladies watching this series, but still, please welcome to the perf driver test drive. Okay, so perf driver and the depth with the depth 1, which means it's nothing to add anymore. So okay, hold on, I just forgot to make I also need to add the recursive call for. Okay guys, just hold on a second. One little more important thing here, because otherwise it won't be working correctly. Just hold on a second, bear with me please. So right over in here, just before we taken back, we need to make a recursive call. So this would be needed in order to dive into the tree of moves and traverse it. So here I would be calling this perf driver function recursively with the only difference, I would say, depth -1. So every time we call this recursively, the depth would be decreased, and all this mode generation stuff would be made again and again and again. So every time this would be made for a different site. So I will now demonstrate you this. I really hope this is gonna work. Okay, so one last thing to consider, just at the very beginning of this first test of this perf driver function, I need to add escape condition. So the condition to escape this perf driver, actually. So we can say if depth is equal to 0, or in other words, we can say like if not depth. In this case, we just want to return from this function, and I really hope now this is it. So let's try to compile. I hold my breath, and I hope this won't give me any errors. Oh my god, it didn't give me any errors. Can you believe this? Oh my god, so is this really gonna happen now? So it's waiting for the user input. Okay, let's see. So we did print the board initially, which is okay, and then we print the board within this perf driver function itself. Okay, just stroke a random key now. Okay, we did the move. We just did the move. You see, like we did move to from D5 to D6, and then take it back. Okay, so it seems like we get a one unnecessary so I need to get rid of one get char there, so let me just stop the execution. So too many get chars. I'm wondering where. So probably, yeah, probably we can get rid of this one. Yeah, save. And oh, sorry. Okay, yeah, this is it. This is it. You see, like the knight is moving, it's capturing something. So until all the knight's moves are exhausted, then we go in with the other knight. Then we go in with the queen. Okay, go in with the queen. Then go in with the pawns. I'm just wondering, did it make a2 a4? Did this make a2 a4? It should have. Or it didn't. Well, obviously it's not the way to how to test this, but still, I'm just really wondering. So did it skip the a4, a2 a4? Well, we'll figure this out. We'll figure this out later on. So now just to demonstrate you how this kind of loops over the moves and makes and takes them back again and again and again. And you see, like, yeah, we also did this castling moves, the king moves, rook moves, all the stuff, and then eventually we did and here. So this was only depth 1. Which meant that we didn't yet cover the responses, the possible responses by the opposite side. But if it just make it, and yeah, also I'm a bit concerned with probably either I missed that a to a4 move or it didn't occur. So I'll definitely need to figure that out, like if it kind of works or not. So I will definitely do this. But before that, let me just try to increase the depth for the perf driver. So from now on, it would now just make a move for white piece, and then it would be looking for all the possible responses of black pieces, and this is known as the depth 2 perf driving, basically. So yeah, we did this d6, we did this. So we had this pawn on d5 initially, right? But then we move this to d6, and now we just trying some responses by black. So now black pieces would try all the possible responses, and later on within the search function, obviously we would be evaluating these positions. Okay, so it's just like all the possible responses, and then you would drop the d5, d6 pawn from d6 back to d5. Well, at least it has to, in theory. And okay, and now it tries another move by white. You see? Okay, now all the moves for blacks are repeated. So this is depth number 2. And now we just increase depth to 3. It would be even more interesting. So it makes the move for white, then it moves the move for black, and it makes the move for whites again. And now it just would be making all the moves for whites, and then he would be making all the moves for whites for another response, and so on. So literally traversing all the possible variations, all the possible approaches, all the branches within this position. And that's the exact purpose of the perf driver, just to walk through all the possible positions within the move tree being generated by the move generator. Well, okay guys, so this is it for this video. I will now be checking out the if it actually works correctly. I'm really concerned about this A4 stuff here. So if it's not generated or some issue is about to occur there or appear there, I will try to fix that, and in the next video, if any issues there, I would just show you what I've done there, so you can synchronize your code with mine and press it further on. So anyway, the next video we're gonna be writing the actual perf task function, which is the absolute milestone and absolute moment of truth. So it would allow us to print the number of positions visited by the perf driver, so we can compare them to the results that are available in public, basically. So there are tables that are telling us how many results we need to get for this particular position, say in I don't know, like in depth 1, depth 2, and up to depth 6, I guess. And that's really enough. And this tricky position is designed so it is capable of tracking the most possible bugs within the mode generator, within the make move function. So literally try to catch every single bug that could be available there. So I hope you've enjoyed this video, because you know, like it's really kind of showing like how our chess engine is getting alive finally. So before this it was kind of too static, but now we see like it's dynamically generating moves. Obviously we'll remove the sprint boards and get chart functions, so we're not going to be interrupting this process by hitting enter. I just wanted to demonstrate you this just in order to show like how computer chess actually work from within. So I've been demonstrating you this by hands on the lead chess side, just moving the pieces back and forth, but here it finally happens just like within it's been produced by the chess engine itself. So this is it from my side, guys. Thanks for watching. Until the next time, and take care.